We have 3 clusters. The management clusters we can access with this KM shortcut, and we can see that we have nothing deployed there apart from MetalLB that we are going to use to expose some services externally. And we have 2 workload clusters that we can access with the K1 and K2 shortcuts. Again, nothing is deployed yet. Let's start by deploying the meshctl CLI. We can use it to easily deploy the different components, but in our case we will deploy everything declaratively using Helm, and we are going to use the CLI just to check the registration of the workload cluster later. So I just download the latest version, and I'm then using Helm to deploy the management plane. So there are 2 Helm charts, one for the CRDs and one for the management plane itself. You can see nothing really special here on the option we set. We mainly just say we want to use like service type load balancer using MetalLB like I said before. So we just need to wait a few seconds for everything to be deployed, and then we need to set some environment variables so that we will let the agents that we are going to deploy in the other clusters know how to access the management endpoints. So I set these variables, and I'll show you here that we have these agents we are going to deploy on each cluster is going to initiate a communication with the management server, and you see it's a one direction, so the management server doesn't need to know how to reach the workload cluster. It's always initiated by the agents. So we can register the agents. We have some security mechanism to prevent someone for registering his own cluster without permission. So first of all, the platform team needs to create this Kubernetes cluster object in the management cluster for the cluster that needs to be registered, and the person who registered the cluster needs to know this token, which is a token that you can rotate, which will be used to initiate the communication the first time with the management server and get the certificate so that we can get a proper MTLS communication established. And you can see mainly the options we set here are telling the agents how to communicate with the management server and the telemetry gateway, which is an open telemetry connector running in the management plane, and that is going to collect all the metrics from the different workload clusters. So we do that for the first cluster, and then we can run the same command for the second cluster, and we can check here what are the different components that have been deployed. So on the management server, we have the management server pods. We have the UI that is using Redis for caching, and the Prometheus server to access the metrics that have been collected through this open telemetry collector that we call telemetry gateway. And on the workload clusters, we see this GlueMesh agent that is reaching out to the GlueMesh management server, and the GlueMesh telemetry collector, which is another open telemetry collector that's going to capture and collect all the metrics from the local cluster. That's a daemon set, but I have just one node here, and then send these metrics to the telemetry gateway. So now we can use meshctl to check the connectivity of the different workload clusters, but we can also see some information about the licensing. We can see that the different components on the management planes are LC. We can see the agents are registered correctly, and we can see that they are both using the same pod on the management server, because we can scale this deployment to multiple pods, and then we can automatically spread the connections of the different workload clusters, so that we can really scale to dozens or hundreds of workload clusters. So we can check this that way. We can also take a look at the UI. So this is the IP of the UI, so I can go there and access it. I can see my 2 registered clusters. Right now I see the version of Kubernetes, but Istio is not yet deployed, so I cannot see any information there. I cannot see anything about the workspaces because I didn't create any workspace yet. And also be aware that we generate metrics also about this agent connectivity. So here we just look at the metrics on localhost on the management server, but these metrics are collected by Prometheus, so we can create some alerts on Prometheus, for example, when an agent becomes disconnected. So we can see here these metrics that are showing us that these 2 clusters, because the value is 1, are currently connected. Finally, we are going to create a special workspace settings. I'm going to explain later what a workspace settings is, but there is a special one that's called global in the management cluster under the GlueMesh namespace that allows the platform team to decide some options that they want to enforce in all the workspaces. And in that case, I want to just define which of the Istio gateways we will deploy later are going to be used for the cross-cluster communication. So I can just simply create this object.